the algorithm to go in this direction. For example, choose one given drug versus another, or it diagnose one disease versus another, or applications, ethical challenges that could be seen in the field of digital health in healthcare around reinforcement learning. Now, let's do a little dive into a subset of machine learning, which is called deep learning. Deep learning sounds complex. It's not very complex, in fact. It's just a subset of machine learning. And I'd like you to look under neural networks on the top left part. You will see here the feed forward. It's very simple. So all the different neural networks that you see, it's a simple classification of neural network, which I particularly like. In yellow is the input layer. Always look at it vertically. So an input layer, that's where the data are coming in yellow. And then in red, this is the output layer. This is where the outcome of the result of the algorithm is coming out. And you can see in the middle, in the concept of the fast forward, you can see actually a green layer, one layer. So an input layer, a processing layer in green, blue, or pink, and then an outcome layer. This is a simple level of neural network. By the way, those neural networks are based on how our brain operates with different neurons, which are connected together and create a network of neurons. We've been doing a mathematical representation of those neural networks inspired from the brain and how the brain works, and created a mathematical model called neural networks or deep learning. Why is it deep? It's because you can enhance the capability of processing by adding more layers. And you can see if you go below and then on the right side, the network are actually expanding to have more and more intermediary layer. The more intermediary layer you are, the deeper the network, hence deep learning. And the more processing capability. The only thing you need to know, and you'll see most of those networks in maximum of 7, 8 layers. A study have demonstrated that above 8, 9 layers, a maximum 10 layers, then you have an incremental decrease in productivity and the outcome. So we're usually trying to stick between 0 and 8, 9 layers maximum. So that's what deep neural network is about. I'll just pick 3 simple examples for you to understand and grab those networks. Very simple concepts. So we'll start with CNNs in the middle top, convolutional neural networks. Convolutional neural networks are a simple form of neural networks which are inspired from animal, in particular birds, but also other animals, visual cortex. And as you know, the brain is just not one entity. It has a large number of subsystems which are connected together and specialize in different areas. The speech, the vision, the hearing, etc., the thinking. So the visual cortex is specialized in identifying pattern, classifying data, etc. So now you can understand why convolutional neural network are classical network, which are used in the field of image classification. Another area, in blue on the left, you'll see the recurrent neural network, RNNs, and one of the cousins, the close cousins on the right side with the long short-term memory, LSTM. Same classification, same families. RNNs are inspired from the auditory cortex, so how we hear things. And they're very effective in order to actually identify sounds, speech, machine translation. That's probably what you use every day when you use, let's say, Google Translate, or when you use Alexa, Siri, and other type of NLP, natural language processing interfaces, because those networks have actually specialized in understanding pattern, speech, and recognition. And then I'll take a last one, just below the pink one in the middle, somewhere in the middle of the graph, you'll see the GANs, G-A-N, for Generative Adversarial Network. And what is interesting with this one is, unlike the others, you'll see a red layer in the middle. So you'll see the yellow, the green, the red, the green, and the red again. Why is that? It's because you have 2 networks attached to each other, right? And that's what makes it very interesting, especially in the field of creativity. And it's something that we thought machine could not do. Actually, with the generative adversarial networks, machine have the ability to then create. How does that work in simple terms? You have the first network, which is the generative network. That generative network is going to come with ideas. So let's say we'd like to design a face, right? From scratch. That generative network is going to create face out of nothing. And is going to submit it to the second part. That's why you have a red output. And it's going to become the input of the second layer. And that second layer is the second part of the network. Is going to look at this and say, okay, hold on, here's my data points of faces, human faces. Is this one looking like a human faces? No, it doesn't. And it's going to keep rejecting until the generative network is managing to fool the other network. And the day it's been fooling the network by actually creating many, many different instances of a face, for example, the network is going to say, hold on, it really looks like what I have in my data set. Yes, I approve it. And that allows us to create from scratch, let's say, pictures, images, which never existed before, face of people that do not exist. And you've heard a lot about that recently with some of the deep fake, which are video or image, which are being animated, or either new faces being created to actually pretend they are people existing when they're not. They're actually fake people. Deep fake are leveraging generative adversarial network technology. So before we conclude this video on artificial intelligence, I'd just like to tell you that, remember Asmara paradox? What you thought was not possible is actually possible. And areas of creativity that we thought were only possible for human beings are now starting to be achievable by some machine. Think about music, think about painting, think about all those areas. So the first, on this slide, you'll see the Schubert Unfinished Symphony. Unfinished because the latter part of the symphony has never been completed. Huawei, which is a Chinese manufacturer of mobile phone, but also a very advanced AI technology, managed with one of its later generation Huawei mobile phone AI chip to actually finish the Unfinished Symphony. And it was actually presented in a symphonical orchestra, I believe in Berlin and in London. The next generation Rembrandt, that's a project by Microsoft, which has actually been thinking, hold on, Rembrandt produced 200, 300, 400 paintings during his lifetime. What if it was alive? He was alive. And then they use an advanced GAN, a generative adversarial network, to leverage the 300 or 400 paintings from Rembrandt and recreate what the next Rembrandt would look like. It's probably an average, but it's quite impressive. And if you go and look at it in the Netherlands, it's now currently displayed in a museum, you can even touch it and feel the volume because they went further than AI. They also 3D printed it the same way that Rembrandt would have printed it by using a machine vision algorithm to identify where Rembrandt would put more volume or more light. And actually they 3D printed the next Rembrandt. So not only it's visually interesting, it's also a feeling that you can touch. Very interesting experience. Fragrance for millennials. This one is a project between IBM and Symrise. One of the things that we think human can do, and only us, is what we call the nose. Nose are those experts which have this very specific nose. They work for agrochemical company, they work for example, perfume company, and they are the only one to really sense, more than others, what's around us. What they've done with this is a company came and asked IBM to actually create from scratch for a given population, millennials, the millennials population so the young people in Brazil, with the target to launch in 2019, so that's coming as we speak, launched the first AI generating perfume. And what they did is they loaded millions of scents from vegetable, from food, from perfume inside, and then they combined it with the expectation of millennial in order to produce the first AI generating perfume. Quite an intense experience. Maybe we don't like it, maybe it's the worst perfume ever, maybe it is the best. We now have to realize that AI can do things that we've never been able to do before. Sculpture, another area. So this one is a Gaudi-inspired sculpture called Thinking Structure, entirely generated by an AI algorithm. And you can see color. The color is evolving using an algorithm that we call sentiment analysis. So people surrounding the sculpture or on social media will have different feelings. And this sentiment analysis will perceive the feeling and it changed the color of the sculpture, entirely AI generated by IBM Watson. Think about movies. Movies is a very interesting area as well. We think we're the only one to be able to script a movie and do it. This one is Sunspring, and this young actor you can see is not really an actor. It's a gig working in a tech company that wanted to play as an actor in this first AI scripted movie. We fed a GAN network with about 300 scripts from different movie, and it came out with a script from a new movie. I'm going to be honest. I watched the movie. It doesn't make any sense, right? And it took me some time to really understand what the meaning, but it is the first step toward a form of intelligence that is able to actually work also on movie. And then last but not least is AI-generated video games. Video games, very complex environment, and NVIDIA, which is one of the world leader in AI chips for video games, has actually produced entirely with AI a video game which is surprisingly realistic to a point where reality is merging with virtual reality. Fascinating experience. And maybe the last thing that you think is not possible and that could become possible is what about your next boss? is a robot. What about your next employee or your next colleague is a robot? What about your next board member is an algorithm? Those things are actually real. So the example of the algorithm, a couple of years ago in Hong Kong, an investment company realized that the 12 board members they had were not making optimal investment. And in order to manage this sub-level of optimum investment, they wanted to have a bit more rational decision making. So they appointed an algorithm to be a formal board member of this investment company. It has so far made quite a few investments and decisions, and it has a voting right equal to the other board member. Quite a fascinating evolution. And then what about your next colleague or your next boss or your next employee? It is already the case that in a number of organizations we're moving towards what we call digital workforce, where a number of autonomous entities, from the very simplest one, like a robotic process automation, is performing a large number of routine tasks for us, to the more evolved, where you have very advanced personal assistants and artificial intelligence algorithms which are exchanging with us, exchanging with our customers. In the banking industry, for example, as well in a few other industries, we already have a large number of interactions as high as 2 million for a few of them per year are performed solely through algorithm with the customer base. So we have to be ready from this merge of the physical digital world and from the evolution towards a world where, remember, human-machine collaboration is going to be central. If you're interested in learning more about those technologies and their application, please check out my other videos on the topic. Thank you very much.